Welcome to NeLI Pod, the official podcast of the National eDiscovery Leadership Institute. Hi, I'm Daniel Gold, your co-host and navigator through the evolving landscape of eDiscovery.
And my name is Brandon Mack. I'm the co-host of our podcast. Our guests, from judges to eDiscovery professionals, share insights that cater to all experience levels.
Whether you're looking for a broad overview or in-depth technical analysis, this podcast is your gateway to understanding and implementing effective eDiscovery practices.
It's important to note the opinions expressed on this podcast are those of the individual guests and the host, and do not necessarily represent the views of their respective employers.
We're here because of our passion for eDiscovery and our commitment to providing free, accessible educational content to legal professionals everywhere. And welcome back to the NeLI Pod, the official podcast for the National eDiscovery Leadership Institute. I'm Daniel Gold, and as always, joined by my fabulous co-host, Brandon Mack. And we are very excited today because we are joined by someone who has literally helped shape the way the legal world understands search and how they understand relevance and how they understand artificial intelligence. I'm excited about this because I used to work with this individual, and I'm glad to call him a friend. And so Dr. Jeremy Pickens, thanks for joining us here today. Dr. Pickens, he is the Managing Director of Applied Science at Elevate. And I have to say, probably one of the most respected information retrieval scientists in eDiscovery. And if you have utilized some version of active learning today, it's because of the work that Jeremy and others have done. And if you've been following this evolution that we've had in eDiscovery from keyword searching to TAR 1.0 to the concept of continuous active learning to now where we are with Gen AI, Jeremy has been at the center of it all. So this is a really happy day for all of us here. And as I said, in full disclosure, Jeremy and I used to work together at Catalyst and then into OpenText after OpenText acquired Catalyst. And Jeremy has not just this PhD in information retrieval, computer science from UMass. He's the co-author of the book that I'm holding over here that was published a number of years ago called TAR for Smart People. I always loved that Catalyst focused in on this idea of not creating a book for dummies, but a book for professionals and calling for smart people. I always thought that was actually really great. And also there's also this other book I'm holding over here, a user's guide to TAR. And yes, Brandon and I both have these books on our bookshelves. So it's great. But anyway, what makes Jeremy special here is this deep technical expertise with also real world sensibilities. He's pushing adopting outcomes, not AI. I love the way that he approaches it. Jeremy, I've given you quite the flowery introduction, but I mean every single word of it. Thank you so much for coming here to the program.
Thank you for having me, Daniel. And if I may counter and say I'm just happy to be part of the flow of eDiscovery. Any ideas or any thoughts that I have pushed forward have their precedents, and they have their antecedents as well. I had a colleague that I worked with many years ago at Fuji Xerox Palo Alto Research Lab out in Silicon Valley, who used to say, your ideas, whether or not they are yours, will be stolen. This idea that we all borrow from each other, we all contribute to each other. And so if I have had some part in that, I'm just happy to be in the flow.
It's also the reason why I like you so much, because you're very, very humble. But I mean, literally off the back of your research, I mean, vendors all over this industry have made, millions and millions of dollars. And it's true. If you think about it, like we had Maura Grossman on the podcast, and I think Brandon was asking the question to Maura about what you have done. Dr. Grossman has basically inadvertently created a ecosystem by which vendors are making millions and millions of dollars, right? And then law firms as well as leveraging the software, et cetera. But here I want to take you back in time, Jeremy, if it's all right during the recording, if I can call you Jeremy as opposed to Dr. J or Dr. Pickens. I hope that's all right. All right. So I want to take you back because one of the things that I've done in my presentations, Brandon has done it as well, to explain technology assisted review or continuous active learning, is this idea that you can give a document basically a thumbs up or a thumbs down. And as we all know, and this is what I often say, is that I'm not a music theorist. I don't have a degree in music, but I do know how to say whether I like a song or I don't like a song. So likewise, we give this analogy some life in the world of e-discovery and say either a document is a thumbs up and automatically the algorithm will service up other relevant documents to you or give it a thumbs down and won't do the same. You have a PhD in polyphonic music retrieval, right? And this is where I really want to go. So, a PhD in polyphonic music retrieval, finding musical patterns and compositions with multiple overlapping instruments. So, my question is how did analyzing the complexity of overlapping music harmonies prepare you to tackle the complexity of legal document analysis? And what are the patterns that led you to seeing that there is similarities between these two?
That's a good question. I gave a talk at the 20th anniversary, so I helped co-organize the very first music information retrieval conference back in the year 2000. Um, and at the 20th anniversary of it, they asked me to come give a keynote about the intersection of law and music information technology. I can't sort of summarize that whole hour quickly now, but what I will say is the perspective that I looked at it from when I was doing the work back then was less so on the thumbs up, thumbs down, here's songs you like and don't like, and it was more on the sense of are there structural patterns within the song, the actual harmonic progressions, the notes, the rhythms that can be traced back to earlier works, right? That you can see sort of rhythmic similarities, harmonic similarities in different pieces of music, and thus see how a composer may have been influenced, or at least be somewhat related to work that has gone on in the past. And finding those connections historically over time between various pieces of music, I think, is very similar to the kinds of storytelling and pattern finding that we want to do in e-discovery collections. What is the story? How did it evolve? How did it change and develop? And can you find historical precedent for something that was said now with something that was said half a year ago, 2 years ago? So that's where that intersects. Of course, the idea of thumbs up, thumbs down is a more general machine learning, supervised machine learning approach. But I like the music perspective gave me the ability to think more about the evolutionary patterns, and not so much just the I like it or don't like it kind of thing.
It's interesting to hear you talk about that and to hear how it may interact with the way we look at text. And one of the things I'm curious about is we've all talked since the explosion of mobile data in the field of e-discovery. We talk differently when we're texting each other, when we're using collaboration tools like Teams and things like that, than we typically do in speech, like in email or something of that sort. Is that sort of pattern detection or evolution detection that you used in looking at music the same sort of thing that you would use in analyzing the way in which our text and speech patterns change due to different mediums that we're collecting data from?
Oh goodness, wow. uh, Great insight. The This is something I haven't done yet, so I don't want to talk too much about it, lest I give those same competitors who made many more millions than I ever did some
Yeah.
ideas. But you think about the short messages, Slack, Teams, text messages. One of the big problems in music was where is the boundary? Where's the semantic boundary of a word? Right? An individual note by itself means nothing, right? An entire piece is too much. But is there a concept of a musical phrase, a short motif, a set of notes together, and where exactly is that boundary that gives you something semantically interesting enough to want to look for that same pattern somewhere else? Um, it's the segmentation problem, right? And that's the same problem we have in short messages, where you have this street. Not only do we talk differently, but you have they're short messages in little bursty patterns.
Yeah.
And when we try to break them up, we break them up into either like 24-hour chunks, or we break them out into well, you haven't texted in the last 4 hours, so maybe that gap in time is where we should break it. But in reality, that's neither of those approaches is really a semantic motif, right? Neither of those really captures the full thread or flow of that composition, if you will. And so there are things that have been done in music information retrieval to find out those semantic boundaries that still are yet to be applied in short message formats in a way that's a lot smarter than we're doing right now.
You talk about information retrieval in ways that I want to say like what 98% of lawyers don't actually talk about, right? And it's worthy of having this discussion, especially on this podcast, to talk about how you look at things. Like, I want you to go into a couple ideas that you talked about, I know in the past when we were at Catalyst together, about this idea of like f-stops and n-grams and back of words. These are concepts that nobody understands. Or I should say, most people don't have an appreciation for why it matters when I need to find a responsive document, right? And why it is that when you code the algorithm the way that you code it, that a certain document shows up. So in, I guess, plain English, can you explain some of these concepts that aren't probably really well appreciated, so as to why it matters when we're choosing a responsive document?
Are you referring to the notion of feature extraction?
That's
And
exactly right. That's exactly
okay,
right.
yeah, the when you're trying to predict text, right? When you're doing supervised machine learning, wrapped up inside of a TAR process, you can only make predictions on based on the substrate representation that you have for those documents. What do I mean by representation? A word with um, oh, you're making me teach a whole machine learning course on the fly. Um,
At a high level,
yeah,
yeah.
yeah, at a high level, I mean, you're familiar with this when you do Boolean keyword search, even, right? You know that if you match the word automobile, it will not match automobiles because those things are not segmented, they're not stemmed. The tokenization for those two words are different. If one of the if in your document the word automobile is actually hyphenated, right? Because it's an older document and we used to talk about auto dash mobiles. That will, if that's tokenized as two separate terms, that will not be captured. And if you've learned the importance of the word automobile in determining relevance through your machine learning, it will not match another document that has auto and mobile as two separate tokens. And so the need to come up with a representation that preserves meaning across the documents is just as important as whether or not you're using logistic regression or support vector machines or naive Bayes or whatever k nearest neighbor. The algorithms that people like to talk and ask about, the feature extraction and the way it's done can be as critical, if not more, to getting a good result from the system. Does that kind of explain it? Do you want to go deeper?
No, I think that's right. I think just the tail end of what you're saying here is that, and I think this is the important concept, and I think what we want to extract from your answer, this is really hard stuff, right? Like, this is not just like, hey, I'm gonna log on, I got this great looking interface, I'm gonna type it in. Like, not a lot of people like really want to know how the sausage is made, so to speak. But man, like, it's important, right? This is important stuff to be able to understand that the word automobile and automobiles, like the tokenization, how it's segmented, it's not the same, right? There is a lot that goes into how that works, and you and others, et cetera, you have all figured that out and been able to surface that up. And I don't know, I take a moment to just, be grateful how remarkable that is.
Well, to be fair, there's a huge community of information retrieval and machine
Sure,
learning for
sure.
whom this is like, their daily bread and butter. It's
Yeah.
very much not just me.
Yeah.
But what one to tie it back to the music, one and this has actually become popular in the LLM era as well, um, is the notion of doing sub document tokenization. Sorry, sub word tokenization, right? So if you have the word automobile, you're not just tokenizing it as a single atomic unit, but you're breaking it up. This is the engrams you mentioned 2 minutes ago.
Mhm.
You're breaking it up into auto or AUT just by itself. Oh me, automobile, the auto, how do I spell automobile? Auto OBIL. Yeah, right. So you've got these little sequences of letters at a subword level, and those sequences of letters can be used to represent the document and to then learn, weight as you're doing your supervised machine learning and make predictions over. Where this is interesting is in OCR. I remember in the community back in the early 2010s, everyone was saying, well, tar doesn't work for OCR documents because there's too many misrepresented characters, misrecognized characters. Um, and the counter to that is that if you've broken up the words into these sub document uh, character streams, you can actually even if the word automobile is misrecognized in one of the documents and the M is recognized as an N, automobile, you'll still have enough of those overlapping character engrams, those character tokens that will match. So that the AUT matches and the OBILE matches and even if the letter M is missing or misrecognized, you'll have enough other words that together paint a picture of the word that was there. And so you can tag one document with the word automobile in it and find a different document with the word automobile because of that.
I I could spend the rest of the time that we have together listening to you talk through these concepts because I find all of these fascinating and getting deep into essentially the guts of how these programs work, the real math behind what makes a certain type of information retrieval, whatever type of machine learning or more advanced AI we're using to get it done. How does it work? I love that. But to allude to what Daniel was saying earlier, we have a bunch of practitioners, attorneys, and litigation support people who are making decisions on specific platforms, and they don't understand all the things that are going on in these multiple layers underneath the platform. They're seeing a UI, they're getting some information about what algorithms are being used and things like that. If you had to consult with someone in that position and they have to make a decision on essentially the platform or the program that is applying whatever is going on behind the scenes, what are the 4 or 5 things that they should be looking for or asking about in order to understand what's doing this the most efficiently and most effectively? Like when you're talking about tokenization and presentation and things like that, are there simple ways for them to know, oh, this program ticks these boxes and this one over here does not?
Oh goodness, that's a really hard question. Um,
Right.
and it's yeah, and I don't want to answer it that way, if
Okay.
that's okay. Because I don't think there's a set of check boxes that that yeah, I know this is the way eDiscovery software is often purchased, right?
Mhm.
Does it do this? Does it do that, right? And there's so much hidden underneath the actual implementation of what that checkbox represents that it's impossible to get a sense of whether or not it will do you right if you have something that meets all these factors, right? Oh, to jump to the tar space, for example, we talk about tar 2.0, cal, right? um do you have it or do you not have it, right? One of the things that I looked at very early on when I was doing my experiments with tar 2 is the rate at which the rate at which the model was retrained, it was updated. And we found that because at the time pretty much all vendors were updating either once a week or at most once, maybe twice a day, right? So you'd get reviewers reviewing documents, putting yes, no decisions on those documents, and then the model would rebuild itself once or twice a day. And or very early on, what I recognized is that the more frequently you rebuild that, the the better the system does. Like without any change to the extracted features, without any change to the core algorithm, without any change to the coding that the lawyers are putting on those documents, just by updating. And we had it down to once every 2 minutes, right? It would a million document collection. You could re-rank every 2 minutes and make use of the most recent uh, uh, review that had been done, and that just doing it more frequently would garner you an extra 15-20% precision, right? It would make a huge difference in the efficacy of the result of the outcome. And how do you boil that down to just like should that be a checklist item,
Right, right.
or is that like and that's just one variable of just like dozens that go into making this stuff work well, and it's really hard to boil it down like that, especially when, oh, how do I say this, when there are complementary design patterns. uh oh good, I'm not ready with a quick analogy for this, but say you're trying to get to the number 9. You can get there with 3 and 6, or you can get there with 4 plus
Mm,
5.
right.
There are two ways to get there. And as long as you get to 9, it doesn't matter like, oh, your system is missing 3. This one has a 3, but you only have 4s and 5s. And it's like, well, but it adds up to 9, right?
Yeah.
And so it's what, and that, Daniel, you alluded to outcome driven purchasing. It's really what it does, not what all the steps are to get you there, right? Whether it's a 3 plus a 6 or a 4 plus a 5, does it add up to that 9 that you really want? And this is something that I find has been really challenging for lawyers, is to be willing to evaluate, not validate, right? Validate happens on a case that you're working on at the moment to see whether you've got to your high recall. But evaluate is something you do prior to purchasing a technology platform, by running your own data through it to see how well it works, and not just like putting a couple documents in and see what ranking looks like, or not just, I think is happening right now. A lot of people are having these prompt workshops for Gen AI where you type in a prompt and you see, oh, look, it makes these calls on these 7 documents. That's great. That doesn't give you the picture of how well it works on the entire 483,762 document set. But how do you do that? You can't sit there and code every document in multiple platforms. And this is where I think the vendors have really needed to step up, and lawyers need to be willing to engage in this, is to run simulations on the platform to say, okay, given that the document has been coded this way, what would have happened, and then run that process all the way through, following the steps that would have happened if if an actual review team had been working on it, and see how quickly at what precision did we get to 70% recall, 80, 85, 90% recall, and so on. And that kind of simulations is something that's been sorely lacking in the community, and we would be so much further ahead if we adopted that mindset, in my opinion.
Well, that would require also, I think, a lot of different software providers allowing for that kind of demo, or that having the sandbox environment to do that. And I'm not sure that's something that I agree, right? That is something that'd be great to have either service providers or software providers or both to be able to provide a sandbox to be able to, as you said, to actually evaluate so that you can then validate. And I like the way that you said that. I want to talk about something else that you have done as well. So I'm reading from the user's guide to TAR because I think this is important as well, because I want to find out what we're doing about this today. One of the interesting things that you did with Catalyst Insight Predict, which was continuous active learning, was you create this concept, or you all create this concept as contextual diversity. And the contextual diversity concept, I don't hear about it anymore, right? Like, I think it was just something that was inside of Predict,
Yep.
and that was it. But that was one of the single most important things that I think that a lot of attorneys really clung on to, was this idea, and it's listed here as contextual diversity is an exploratory tool found only in the Inside Predict system that runs automatically as part of a TAR project. And it goes on to say that it adds in exploratory documents to help make sure you've looked into all the corners of your document collection, even the ones you don't know about. So what I read that, and I obviously know this because of my time there, but it was about finding the negative, right? Finding out what you don't know about documents. Can you talk about contextual diversity in your own words, and then if you're seeing it in any other application at all?
Oh, yeah. So what's the date on that book, that version of the book?
Well, this is copyright 2017.
2017. Okay. So to my knowledge, in 2018, one other vendor did come out with a contextual, a diversity type of algorithm. A lot of times coverage algorithms, so uncertainty sampling is passed off as diversity, but it is not. So to my knowledge, I think there's only one other vendor that had ever also implemented that. I don't That's to my knowledge. I don't want to malign any of you out there who are like, hey, he didn't. I know of three others. What is he talking about? Um,
But talk
it,
about why it's so important, though.
well, it's because you don't know what you don't know, right? This is a concept in information retrieval, right? Not machine learning. This is a concept that came from the information retrieval community. It goes back to 1980 with a professor named Nick Belkin, who was at Rutgers for many years. Called anomalous states of knowledge. Ask, this idea that you when you ask for something, it's because you know that you know it, but you don't know what to ask for, something that you don't know exists. And so the thing that a machine learning algorithm or just a clever algorithm in general has, the advantage it has over the human, is that it can look globally across your entire document collection, and it can see what documents you have been exposed to, right? Which documents you've put thumbs up, thumbs down on. And that's both thumbs up or thumbs down, right? Positive or negative. It knows that you know something about them because you've interacted with them. And it can then also look over every other document that hasn't been interacted with, right? That a user hasn't coded. And it can say which of these are most unlike anything that I've ever seen before. And because it has that global view. And furthermore, it can do that in a way that says, there may be one document with a single word in the collection that you've never seen before versus 5,000 documents with words you've never seen before. And you can prioritize it to say, well, get me to the 5,000 document pocket before you get to me to the one document pocket. So it starts in the biggest pockets and iteratively gets you down to smaller and smaller and smaller pockets of the documents that it knows that you know nothing about. So it's sort of fulfilling that ask hypothesis for you.
Yeah, I think in a related thing that was very interesting to people when Cal first came out, and one of the things that was most attractive to it was we were used to a world in which the story was the only way that you could train a model was by having massive amounts of data that you could give to it to get it started. You have to, I think in the early days of applications of TAR, it was, 2,500, 3,000 documents, something like that before you could even get started. And then Cal comes along and says, oh, well, we can get the model started with your first document or your first 10 documents. And then along the way, you have things like contextual diversity that are added along into the process. Can you talk to us a bit about how what we could call the cold start problem of TAR was solved with Cal, where we got to the point where a model could start learning from document one and not make us do 2 days worth of work before we could even start to see initial results?
It's really simple. Uh, Anytime you have signal, you can exploit it, right? So even a single coded document gives you some information, and you don't. Here, let me back up. Um, there's a larger picture here, I think, that has gotten lost. And I'll try to do this as quickly as possible. But let's go back to your pre-Socratic Greek philosophers, right? You remember them, right? Socrates revolutionized Greek philosophy, but before then there were a bunch of smaller, lesser named philosophers that paved the way for a lot of Socrates' work. Two of those philosophers were Parmenides of Elea and Heraclitus, right? What was Parmenides known for? Parmenides, his idea was that the world reality is a single, unchanging, eternal constant, just being, right? That's all that there is, and that any change that we see in the world, in any distinguishing characteristics, any flux, it was just an illusion because the underlying reality is solitary, unitary. Heraclitus, on the other hand, um, was more of the philosophy that everything is in constant flux, right? You might have heard the phrase, no person can step in the same river twice because the water has moved on. It's a different river, and that person is a different person, and nothing is ever constant. It's always changing, and the idea of tar one versus tar two, of sal versus cal, and by the way, we've forgotten the acronym sal. It's just as valid as cal, but somehow we no longer use it. Um, is is that of Parmenides versus Heraclitus. So tar one, the traditional way of doing tar, is the notion that there is some underlying, unchanged, eternal representation of what the case is about, right? That there's some model, like, and in order to make, and our goal is to look at the documents in the collection, the surface illusory changes, and to try to understand what that eternal um, representation is. Does that kind of make sense? And so, in order to really get a sense of what the real underlying unchanging nature of what the case is about, you have to look at thousands of documents to get a sense of that, right? And so it's not that the models can't be used a different way. It's that we had adopted a Parmenidean concept of what tar should be. Uh, the insight with Tartu, or Cal, is that the world is Heraclitus. The world is in constant flux. Um, that all you have to do is you don't have to worry about building an unchanging model. You just have to take the next step because the next step after that will change again, and the next step after that will change again. And as long as you're constantly adjusting the path that you're taking, you will be fine. And we built it with that concept in mind, and it turned out that not only does it work better, but it solves a lot of issues like rolling collections, of needing to have a junior versus a senior attorney for training, of a lot of the issues that come with static trying to come up with a static Parmenidean representation of the case. And by the way, just as a quick aside, I know it's unpopular to think of Gen AI as tar. It is. Sorry, flat down. It is a tar process because it is tar because tar is a process, not a predictive model. And what you see is that using Gen AI, not only is it a tar process, it's a tar one process. It's a Parmenidean process because what we're trying to do is we're trying to look through the collection and come up with that universal unchanging prompt that models what the case is. And then once we've done that, then we take that and we apply it to the rest of the collection. That's tar one.
That is hands down probably the quote of this entire show here today. Brandon, you and I have heard something similar to that before, but the way that you talk about that, about how it's just a process, I think that's really interesting. And so that actually leads me to You were, and I mentioned this in the front end, you were the recipient of the 2025 Relativity AI Visionary Award. And you said, and it's on the Relativity website, you could go and visit this. You said, while AI is transformative, it simply can't replicate the nuance, judgment, ethical considerations, and strategic thinking that are the hallmarks of effective legal practice. AI frees up our time from routine tasks, allowing us to focus on complex legal challenges and provide personalized guidance to our clients. So I love that because you focus on the task at hand, right? Then it's the task, right? So AI, and I heard somebody else say this recently, AI is not replacing jobs, AI is replacing tasks. And I like that. But Jeremy, Tar and Cal is AI as well. And I think that that's lost on people, right?
Yes.
Right? It's lost on people. And so, and so I want you to dig into this for us, please, and all of our listeners, because we treat this as Gen AI as like this is the first time we're ever in the world learning about AI, but my God, it's been around forever. So can you walk through this a little bit? And in the context of this quote that I just mentioned just now as well.
I'm not sure where to go with that. Can wrestle with me a little bit more.
Sure. So you're talking about how AI freezes up from routine tasks. AI is transformative, but
Yeah,
AI has been around. It has been around for a long time. What you were working on
for
with
70
Tar,
years. Yeah,
Yeah,
right?
yeah,
So what you were working on with Tar and with Cal, it is equally as transformative. When Arthur Samuels in 1956 taught the machine how to learn how to play checkers,
right.
that was where the phrase came from, machine learning, right? So they literally taught a machine. So that was transformative. And uh, one could argue, as you have just said, how Gen AI is similar to TAR 1.0, that when we are focusing in on training a document in TAR or in Cal, the same way we are leveraging a prompt to train the documents, it's the same saving us time with routine tasks, is it not?
Yeah, in the sense that it it would I think I'm gonna I'm gonna I'm gonna read the definition of tar to help us frame this. Um, so from the 2013 Grossman Cormack glossary, Maura Grossman was the person who made up the term tar. I mean, it's her term. We can't tell her what it's not if it's her term. And literally it says tar is a process for prioritizing or coding a collection of documents, right? It's for automating those routine tasks by using a computerized system that harnesses human judgments of one or more subject matter experts on a smaller set of documents and then extrapolates those judgments to the remaining document collection. Right. So it's not just machine learning in the sense of having an engine that learns from documents. It's a process wrapped around machine learning for by which you pick the documents, you learn from those documents, you build an extrapolation engine, and then you extrapolate. Gen AI, with traditional supervised machine learning, the machine looks at the documents that you've coded, induces a model, and then from that model extrapolates over documents you haven't seen. Right? With Gen AI, the human looks at documents that have been coded, or at least in their mind, they look at it and they know that it's relevant or non-relevant, responsive, non-responsive. The human looks at it, creates a prompt. So the human induces the model because a prompt is a model. A prompt is a Parmenidean representation of the unchanging eternal nature of what the case is about, right? But the human does that learning, and then that prompt extrapolates, through the LLM itself, extrapolates onto the rest of the collection. Right. So the only difference here, and so that whole thing, that's AI, right? It's it's except you're just using a human for one portion of it. You're going from instead of the machine going from documents to your Parmenidean model. It's the human going from the documents to the Parmenidean model. Other than that piece, the rest of it, I say, is is exactly the same. Um, does that get at what you're?
It does. I mean, what you're addressing is fascinating concept, and I guess the question is like, why does it matter, right? Why does it matter to anyone if they're simply just going into a database and they're going to search for documents? And the algorithm is just going to do its same and just take it for granted, right? But it matters because of the ethical requirement that we have to understand the technology, not to the level that you will, because you are smarter than I will ever be in six of my own lifetimes, right? But to understand it at a level enough in which it can be defended or prosecuted against either in either direction in court, so that it could be understood.
It could be understood, and that you're doing it right.
More importantly, that you're doing it right, right?
And here's like I was flabbergasted. Saying that word, does it make me sound 120 years old? I was shocked by something I saw over the summer. A major vendor, and I don't mean to throw anybody under the bus, so it's not like who cares who it was, but there was a major vendor describing their Gen AI process, and what it is was selecting a bunch of documents. The human then reads those documents, writes the prompt, tests the prompt on the very same documents that they were reading, and then see how well the prompt does. Does it predict those things that the human called? By the way, the human still has to code the documents, right? Responsive, non-responsive, to see how well it does. Right? So you're not getting away from having to do any training in that sense. So the human is still coding those, and then if it doesn't work, you go back and rewrite the prompt based on the documents that you're getting wrong, that the prompt is getting wrong. Rewrite the prompt and then test it again. Rewrite the prompt, test it again, and go around that loop a bunch of times. And then when it looks like the prompt is doing well on those documents that you've selected, then you run it on the rest of your collection. Right? You do the extrapolation step. Do you see the problem with that? The problem with that is that you are training on your test set.
Yeah.
You are contaminating you think that you've learned a universal Parmenidean representation of the case, but what you've instead done is you've focused yourself too narrowly on just those documents you've read from the case rather than on the documents as a whole. This is why in traditional TAR 1, people had something called a control set. And the control set was a set that was not used to learn from, whether it's the machine learning from it or the humans learning from it. You were not allowed to learn from it. And you would code this control set so that in the process of inducing your extrapolation algorithm, your Parmenidean representation, whether it was the prompt or the support vector machine, you could get an unbiased, independent measure of whether it was useful on the rest of the collection. That was the control set. We have because we seem to have collectively forgotten or never realized that Gen AI is a used for eDiscovery is a TAR process. We've forgotten what control sets are, and we're now like surgeons who go into surgery without washing our hands first. Well, this is different. I write prompts, and so germ theory doesn't exist. No, germ theory is still there. You still have to be clean about the way you separate your data and the way you learn from it. And we've learned all those lessons for a decade and a half. Uh, and we've completely forgotten about them because somehow it's different now that it's an LLM. I don't understand that, and I don't buy that.
It's interesting hearing you answer that question, and a number of the things that you brought up there. It's not just about the technology; it's about the process, and in that process, there are roles. And what you're saying that TAR 1.0 view of Gen AI, we're just seeing a role reversal of what the computer is doing versus what the human is doing. When we were prepping for this podcast and I was looking at your bio, so one of the projects that you had worked on at the Palo Alto Labs was an information retrieval project or search project that allowed multiple humans to collaborate and to search collaboratively in real time with one another. And I found it really fascinating because I thought, how do you divide up the roles, or how do you get people to work together in a way that as a whole, they're not stepping on each other, but it actually becomes a better process through that collaboration. And it reminds me now of what we're talking about here, where we're trying to redefine or get people to understand what the proper role is as technology advances. There's still always a human in the loop role. That role may change, but as it starts to change or as the technology changes around it, how do we understand what our role should be, the places that we should play, and the places where we should use AI to execute certain tasks? And do you think that that Palo Alto project is at all informative on your thoughts on those
Oh my
roles?
goodness. I can't believe you found that. That is of
We
all
do deep research here on the
We
podcast.
that's great. I believe you now. That of all the work I've done over my career so far, right? Who knows what's to come, but so far, that work was my favorite piece of research. And I would say that that was the bridge between music and me joining the eDiscovery industry in 2010. What happened there? Just a little history, man. We need so much more time. Uh, is I was no longer doing music information retrieval. I could not get any of the big Silicon Valley players to be interested in it. It was just too early days. This is 2004, 2005. iTunes barely existed, if at all. YouTube was just barely out of the. No, nobody was thinking music information retrieval. So I switched back to text retrieval at Fuji Xerox, but I was still trying to be inspired by some of that early music work that I had done. And I was sitting in the office at Fuji Xerox with a woman named Mary Beth Back, one of my coworkers, and we were trying to think what is there from the music domain that could be relevant. And we came up with the idea of a jam session, right? Where you're a bunch of musicians sitting around in the room and you're playing off each other. You're hearing the patterns that somebody's generating and you're picking it up and going with it. You know, and we thought, well, could we not apply that to information seeking? And that was the collaborative search idea. So think of it as improvisational jazz with a bunch of collaborating musicians. There's so much more. I tried to bring some of these ideas into eDiscovery back in the early 2010s. Nobody was having it at the moment. I still think there's room for it, and I actually have some ideas about how you could actually use Gen AI to facilitate that a little bit better. Um, but it's I'm giving you history. I'm not answering your question. It, it's yeah, there's room for it. There's room for an algorithmic AI driven back end that coordinates the activities of multiple people on the front end uh, in a very, I would say, again, Heraclitean way. That flux, that flow. That's what the back end AI should be optimizing for, allowing the people to work together in a way that gets you to a collaboratively arrived at approach. I really didn't answer the question, did I? It was very vague.
We were asking you to dig deep, go way back on
Yeah.
that one.
Jeremy, we'd be remiss if we didn't say, first of all, we want to thank Elevate for being a gold sponsor at the NeLI conference in 2025. We think that's fantastic, and we really appreciate the support that Elevate has given to NeLI and obviously to the community. So it's wonderful having Elevate as a sponsor. Uh, as we look to the next, we used to say 3 years, but we look to the next like 3, 6, 9, 12 months as we wrap up here, Jeremy, what what does it look like? Be our crystal ball, be our future predictor here.
Can you how many minutes can you edit out of this script? Make it sound like I gave an immediate answer.
Oh, we've got the best editor for this show. Don't
Yeah.
worry.
Oh goodness, crystal ball. I think people will start to relearn the lessons of Tar 1. I think people will become more creative in how they use Gen AI. And unfortunately, what will not happen is people will not do a direct side by side comparison of Gen AI and traditional techniques, which they really, really should. There are, think about it like golf. You don't use the same club from every position on the course. right? You use your driver in some places, you use your wedge in other places, you use your putter in other places. Cases are similar. I think we now have an additional tool in our toolbox, and there are places to use a continuous learning, traditional supervised machine learning approach, aka supervised machine learning TAR. There are places to use a Gen AI based TAR 1 approach, and there are places to use a supervised machine learning based TAR 1 approach. Each of those have different affordances, different cost points, different effectiveness points, and learning which one is useful and when. There will be some indirect learning over the next 6, 9, 12 months, but I think people will not be focusing on it as much as they should. I do not believe in one approach to rule them all. I believe in situational dexterity. One other point that I really wanted to insert, which it's the notion. So, like, I was having a conversation this past June with someone, and I realized, let's talk naming. Let's talk Parmenides versus Heraclitus. I realized that people never really understood. Either they forgot or we never quite explained where the TAR 1 and TAR 2 names came from. Right. First of all, it was John Tredenik at Catalyst who gave it that naming. So I'm not going to take any credit for it. He gets all the credit. But people sort of looked at that as an ordinality, right? Two is better than one. And so then you had a bunch of people saying, well, this is TAR 3 and this is TAR 4. And you're right. And where it came from was when I was discussing this approach with John in the very, very early days. I was giving some version of the Heraclitus versus Parmenides. I wasn't using those words, but I was giving some version of the notion that one you try to learn a model, and the other one you try to optimize for the flow, right? And he was like, "Oh, that's like Web 1 and Web 2." So think back 20 years, what was Web 2.0? Web 2.0 was the notion of the dynamic web, that a web page isn't static, that a web page you can interact with, and as you interact with it, it changes constantly. Now, today, that's just part and parcel of the way the web works. Everything is Web 2.0. Your eDiscovery is done in a web browser, and it's interactive. Your Gmail it's all. But 20 years ago, the web was static. So what you had is a very Parmenidean, some amount of iteration, right, to create the newspaper article. Like that was an iterative process to create the content in a newspaper article. But then once that content was you were done iterating, it was fixed and it would be served up in a static web page. That's TAR 1, right? Iterate for a short period of time to come up with the thing and then serve that static thing indefinitely out to the rest of the web. Just like you learn a model and then serve it indefinitely to the rest of your documents. TAR 2 is the Web 2.0 that it's constantly in flux. So 1 and 2 are not ordinal numbers. There is no such thing as a 3. There can never be such thing as a 3 because it's not ordinal, it's categorical. TAR 1 and Mora's terminology. Mora's terminology was simple learning, simple active learning. So the active just means how you pick the documents. But the notion of the simple in simple active learning is the same as TAR 1. You have some finite period of duration in which you're learning a model, and then you extrapolate. And continuous active learning is the notion of Heraclitus, where it's in constant flux. So simple learning and continuous learning are the same concepts as TAR 1 and TAR 2, are the same concepts as Parmenides and Heraclitus. There is never and will not ever be a TAR 3. Now, that won't stop here's my other prediction. That won't stop the world from proclaiming the next TAR 3 or as they haven't done. But does that make sense? Like
it does.
You're either one or the other, right? You're either the fundamental nature of reality is static and unchanging, eternal, or the fundamental nature of reality is constant flux. There is nothing else other than those two things. That's your TAR 1 and TAR 2.
Which one is it, Jeremy?
always been a fan of Heraclitus. I just love that.
That's a fantastic answer to end on as we wrap things up. And I hope that the industry can prove you a little bit wrong and that people are a little bit more circumspect in evaluating what's the right tool for the right job. But I will say, on behalf of Daniel and I and all of our listeners and everyone in NeLI, thank you very much for the time you spent with us today. It's been a fascinating conversation, and we really could spend hours more talking through. It's just tip of the iceberg conversation today. So many things that we could have gotten into much more deeply. But thank you very much for taking the time and sharing with us.
You're welcome. My pleasure to be here.
If you've enjoyed our discussion and want to learn more, don't forget to subscribe to our podcast on your favorite streaming platform. We're here to help you stay on top of the latest trends and developments in eDiscovery.
We'd love to hear your thoughts and questions about today's topic. Reach out to us via our social media channels or email us directly. Your feedback makes our program stronger and more attuned to the topics you care about in the world of legal technology.
Remember, all the resources and insights shared today are aimed at enhancing your practice and understanding of eDiscovery.
Join us next time on NeLI Pod as we continue to bring you expert knowledge and lively discussions. Until then, keep innovating, keep discovering, and keep pushing the boundaries of legal technology. Thank you for listening, and we'll see you next time.